Hey there, science fans! Ever heard of water pulling a disappearing act? Okay, maybe not disappearing, but how about boiling and freezing at the same time? Sounds crazy, right? Well, get ready to have your mind blown because today we're diving into the wild world of the triple point. This is where water throws a scientific party and its solid, liquid, and gas forms all hang out together. Get ready to explore this awesome phenomenon. Water is amazing, we drink it, we swim in it, we need it to survive. But did you know it can also pull off some pretty mind-blowing tricks? One of the coolest tricks is something called the triple point. Imagine this. You've got a pot of water and somehow it starts bubbling like it's boiling, but then ice starts forming at the same time. That's the triple point in action, a point where water exists as a solid, ice, a liquid, water, and a gas, water vapor, all at once. This isn't some magic show illusion, folks. It's real science, and it all comes down to the relationship between temperature and pressure. So buckle up as we explore the science behind the triple point and learn how to recreate this mind-boggling phenomenon right before your very eyes. But how is this even possible? Let's explore the science behind this fascinating phenomenon. The triple point is like a big science party for water where all its states of matter show up. We're talking solid ice, liquid water, and gaseous water vapor, all coexisting peacefully. It's like a three-way tie in a game of tug-of-war. Now, to get this party started, we need the perfect temperature and pressure. Think of it like Goldilocks looking for the perfect porridge. For water, that sweet spot is a chilly 0.01 degrees Celsius, 32.02 degrees Fahrenheit, and a pressure about 1/100th of what we feel walking around every day. To really wrap our heads around this, let's look at a phase diagram. It's like a roadmap for water's states of matter. Picture a graph with temperature on one side and pressure on the other. The triple point is where the lines separating solid, liquid, and gas all meet. But hold on, there's more. This special point isn't just about water throwing a state of matter party. It's also a super precise reference point used by scientists to calibrate thermometers and ensure accuracy in their experiments. Pretty neat, huh? Alright, science adventurers, are you ready to see the triple point in action? Good news! You don't need a fancy lab to recreate this scientific magic show. With a bit of careful setup, we can witness this phenomenon right at home. Picture this. We've got a special container hooked up to a vacuum pump. This pump is going to help us lower the pressure inside. Now let's carefully introduce some water into our container. As the pressure drops, watch closely. The water will start to boil, just like when you're making pasta. But here's where it gets really interesting. As we keep lowering the pressure, something amazing happens. The boiling water starts to freeze. Yep, you heard that right. We'll see ice forming while the water is still bubbling away. That, my friends, is the triple point in all its glory. This incredible phenomenon happens because of something called latent heat. It's the energy that's released or absorbed during a phase change. Think about it like this. When water boils, it needs extra energy to transform into vapor, and when it freezes, it releases energy as it turns into ice. At the triple point, these energy exchanges are perfectly balanced, allowing all three phases to coexist simultaneously. Section 4, the Balancing Act, Thermodynamic Equilibrium at the Triple Point. The triple point isn't just about water showing off its multiple personalities, it's also a fantastic example of thermodynamic equilibrium. At this special point, water's three states of matter are in perfect balance. It's like a three-legged stool that's perfectly stable. Imagine a seesaw with ice on one side, water vapor on the other, and liquid water right in the middle. At the triple point, this seesaw is perfectly balanced. No one is winning or losing the tug-of-war. But here's the thing, this balance is delicate. Even the slightest change in temperature or pressure can tip the scales, causing the water to shift into a different state. It's like a game of Jenga. One wrong move, and the whole thing comes crashing down. This delicate balance makes the triple point a crucial reference point in science. It's used to calibrate thermometers and ensure accurate measurements in various fields. So, the next time you check the weather forecast, remember the triple point, the unsung hero of accurate temperature readings. Section 5, Setting Up Your Science Show. Experiment, equipment, and safety. Ready to recreate the triple point magic at home? Awesome. Here's what you'll need. A vacuum pump, the heart of the operation. A sturdy container to hold the water. A way to monitor the pressure inside, a gauge will do the trick. And of course, some good old H2O. Now, before we get this science party started, safety first. Working with vacuum pumps and pressure changes requires caution. Make sure you're in a well-ventilated area, wear appropriate safety goggles, and handle the equipment with care. Remember, science is fun, but it's crucial to prioritize safety. Once you've got your safety gear on and the equipment set up, it's time to carefully follow the instructions. Remember that patience is key. Achieving the triple point takes precision, but trust me, the moment you witness that water boiling and freezing simultaneously, you'll know it was all worth it. Section 6. Beyond water. Triple points and other substances. Water might be the life of the party when it comes to the triple point, but it's definitely not the only one with this cool trick up its sleeve. Many other substances have their own unique triple points, each with its own set of conditions. Take carbon dioxide, for example. You know, the stuff that makes dry ice so cool, pun intended. Its triple point is much colder and higher pressure than water's. At this special point, you can actually have solid dry ice, liquid carbon dioxide, and gaseous carbon dioxide all hanging out together. And it's not just these two. From metals to gases, every pure substance has its own triple point. It's like a fingerprint that helps us understand and define its unique properties. So, while water might steal the show with its triple point magic trick, it's important to remember that it's just one example of this fascinating phenomenon that exists throughout the universe. Section 7. Triple point in action real-life applications. The triple point might sound like something straight out of a science fiction movie, but it actually has tons of real-life applications, from cooking to cutting-edge technology. Ever used a pressure cooker? You've witnessed the power of manipulating pressure to change the boiling point of water. By increasing the pressure inside the cooker, we can make water boil at a higher temperature, allowing food to cook faster. It's like a culinary time machine. And speaking of pressure, did you know that at high altitudes, where the air pressure is lower, water actually boils at a lower temperature? That's why it takes longer to cook pasta when you're up in the mountains. But the triple point isn't just about cooking. It plays a crucial role in calibrating thermometers, ensuring accurate temperature measurements in countless fields, from healthcare to manufacturing. It's like the unsung hero of accurate measurements. So, the next time you encounter the triple point, remember that it's not just a cool science concept. It's a fundamental principle that impacts our lives in countless ways.